For today, we're going to look at one more section of Chapter 8, which is areas of triangles. You'll be doing problems with these area formulas today and tomorrow, and then on Wednesday, there will be a quiz on law of cosines and area of triangles. In geometry, you learned that the area of a triangle is 1/2 its base times its height, which is great when you know the base and height of the triangle. And remember, a base could be any side. The height is the length of the altitude that goes to that base. So it has to be a perpendicular segment from an opposite vertex to that side. So if you know those two things, you can find area quickly. And the first triangles you found areas of were right triangles, where the base and the height are the two legs. It ends up that you can find the area of any triangle if you know two sides and the included angle. So we need to know the lengths of two of the sides and the included angle. The included angle is the angle between them. Here's a quick look at why this works. Say that I know these two sides, A and B, and the angle C that is included between them. If I know those values, I could draw in an altitude, for example, here. Right now, the base of this triangle is B, and my altitude is this length H. If I know that length H, I can find area. I can find H if I know A and C, because if I look at this triangle, this small triangle is a right triangle with angle C that is opposite of the leg H and the hypotenuse A. So the sine of angle C would equal the opposite leg over the hypotenuse. In other words, that height H would be equal to A times the sine of C. So my base is B and my height is A sine C. So I plug into area equals 1/2 base times height. And usually we write this in a way that's just a little bit quicker and easy to remember. We said the area of a triangle is 1/2 AB sine C. Now, again, the letters are arbitrary. What's important here is that A and B are two side lengths, and C is the angle between those two sides. So we also could write this as 1/2 AC sine B, or 1/2 BC sine A. It's always two sides and then the sine of the angle between them. And not every triangle is A, B, and C. So just choose the letters, two side lengths, sine of the angle between them. There's one other way that we can find the area of a triangle if we know all three side lengths. This is called Heron's formula. Heron's formula says the area of a triangle with sides A, B, and C is equal to the square root of S times S minus A times S minus B times S minus C. So then the obvious question is, what is S? S is semi-perimeter. So S is the perimeter, A plus B plus C, divided by 2, semi being half the perimeter. So if you're going to use Heron's formula, you have to know all three side lengths, A, B, and C. You take the perimeter and divide it by 2 to get S, and then you multiply this all out and take the square root. Here are a couple quick examples. Basically, in each problem, you're first going to decide, am I using 1/2 AB sine C, or am I using Heron's formula? You're going to write the formula with the numbers plugged in, and then go to your calculator. These should be pretty quick. So if I look here, I have a side, and an angle. And I don't even have to have the sides labeled. All I know is it's two sides and the angle between them. Area is 1/2 AB sine of C. And then again, our calculator should be in degree mode. And I'm going to do 1/2 times 2 times 5 times sine of 20. And the area of this triangle is about 1.71. If there were units, give me square units for area. Over here, we are given all three side lengths, so we're going to use Heron's formula. Before I go to Heron's formula, I'm going to calculate the semi-perimeter. Add up the three side lengths and divide by 2. And I get that the semi-perimeter is 9.5. Once I have the semi-perimeter, I plug it into Heron's formula, square root, the semi-perimeter, and then it's multiplying the semi-perimeter minus each side. So 9.5 times 9.5 minus 6 plus 9.5 minus 8. And I multiply those all together and take the square root. Don't forget to take the square root. And I get that the area of this triangle is about 14.98. So go to two decimal places, know these two formulas and how to use them. And then, as I said, this will be the last section in Chapter 8 that we are covering.